Hello everyone. Greetings to all the 𝐚𝐿 managers who are watching this video from Raghavan Vorpak Group of Companies, Pune. I am a HVAC refrigeration specialist with 38 plus years industry experience. I worked for two American corporate companies in India for a very long time, and currently I manufacture hot water heat pumps and industrial process chillers in Pune. I received a lot of encouraging words from some of you 𝐚𝐿 managers out there. I will try to incorporate some of your suggestions and try to answer some of the queries in the subsequent episodes. Thank you so much. One interesting discussion I had with one of the 𝐚𝐿 managers recently during my industry visit to evaluate practical applicability of a heat pump there was, he was asking me, I have solar water heating system, so is the heat pump going to help me further? The answer is no, because from the sun through solar heating, if we are generating hot water, nothing more could be better than that. But heat pumps do complement the solar water heating process, particularly during the night time, monsoon season, cloudy weather conditions, when the sun is not shining and we don't get very good output of hot water from the solar hot water system. Definitely heat pump helps to complement the heat output from the overall system. So this is how we think and try to implement the heat pump projects. Always complement whatever is naturally available from renewable energy sources. Good. In today's episode, we are going to discuss how a typical air to water 80 degrees centigrade industry hot water heat pump works and what are the parameters, what kind of COP we get, etc. Let me start. So taking a 500 liter tank that we want to heat up to 80 degrees centigrade, it's a standard air to water standalone heat pump. So we are taking atmospheric air. So the refrigeration system consists of a air cooled evaporator, finned coil with fans to circulate the air. Second is there will be a water heating scroll compressor, which are more efficient than reciprocating and other type of compressors. There will be a shell and tube heat exchanger condenser, which is generating the hot water. There people may be using or might have seen different types of heat exchangers also for the condenser, but usually industrial application should be long lasting, at least should be serving for 10 years, 15 years, 20 years. I prefer to use shell and tube condensers because they are very easy to descale. The way you may be maintaining some of the big chiller plant water cooled condensers by descaling them using your regular scheduled maintenance. So similar way you will be able to maintain the shell and tube condenser of hot water heat pump also. And then it will be having expansion valve and all other standard refrigeration accessories in the system. It will be having a circulation pump, taking the hot water from the storage tank, pushing it, passing it through the shell and tube condenser, giving it back to the thermal storage tank. Now once we switch on the system, the pump is going to circulate the water. Let us say we start with 25 degrees centigrade water temperature in the tank. So assuming we have designed the shell and tube condenser for a 5 degrees centigrade delta T, 25 degrees centigrade water enters from the tank. The outlet from the condenser goes at 30 degrees centigrade. So when it circulates in the tank with the water, storage water, automatically you will see an incremental increase in the storage temperature. So 25 becomes 25.1, 25.2, slowly it keeps increasing. As the tank temperature increases, automatically the output temperature, because the delta T is 5, the output water temperature also increases. So over a period of time, you will be monitoring, witnessing the 25 degrees centigrade water temperature reaching to 35, 45, 65, 75, 80 like that, whatever is your set temperature. Usually talking about the standalone air to water heat pump, I prefer to have ultrasonic water flow measuring device deployed in the hot water heat pump itself, two temperature probes, one for the inlet to the shell and tube condenser and one on the outlet side. So once we know the delta T, you are also measuring the water flow rate through the condenser. Automatically we know what is the heat output capacity, convert that into watts. So you know how many kilowatt heat output you are getting from the heat pump. I also prefer to have a electrical energy meter installed in the electrical panel So any given point of time, you know what is the COP the heat pump is delivering. Now many of you people who are well versed with the electrical heating system, you know whenever after the weekly off or 2-3 days vacation, when you come back start, you have to start from 25 degrees centigrade of the degreasing solution or whatever solution you are going to heat up. So depending on the kilowatt of electrical heating element you have installed, it's going to take its own time, right? Total heating capacity divided by kilowatt of electrical heaters installed. So many hours of heating time normally you allow before you start your manufacturing process. With the heat pumps also it is the same principle. The higher the kW capacity of heat pump you have deployed, the shorter will be the heating time and vice versa. Now many of you might have seen, assuming you have a 24 kilowatt electrical heater, the 24 kilowatt input remains almost the same unless you have a thyristor drive, you are switching on and off, etc. Almost it remains constant throughout the heating process from 25 degrees centigrade to 80 degrees centigrade. So you may be a little surprised, the power consumption, input power to the heat pump will not be constant like a electric heating element, because this works on refrigeration principle, right? So when you start at a 25 degrees centigrade solution temperature, the condensing temperature is low, evaporating temperature is low. So the scroll compressor power consumption is directly proportional to the condensing temperature. Lower the condensing temperature, power consumption is very low. Higher the condensing temperature, power consumption increases. So when you are instantly calculating the COP, when the water temperature is 25, 35, 45 like that, you will find the COP is very high when the water is at 25, 30. The COP starts reducing to maybe about 3, 2.5 like that when the water is reaching about 60, 65. And by the time it reaches 80, you will see that the COP is around 2. Sometimes it could be 1.7, sometimes it could be 2.3, depending on what all other electrical equipment you have added in the heat pump design. So this is how it works. So whenever we are calculating the heating time and overall energy consumption, the COP calculation, we always take the overall integration of this entire heating time, then we work out what is the COP. We don't go by any instant number. We calculate during the total heating time how much energy has been consumed. So here if our electrical panel has an energy meter, it automatically helps to see what is the COP of the heat pump to raise a particular liter of volume, a degreasing solution tank or any other tank from T1 to T2. So this is something very interesting. Now many of you may also ask, many a times whatever COP has been claimed, I don't get it in the real life scenario after the project has been implemented. So why this happens with practical values, let us take this example in the next episode and go into the details. So if you like this video, my coordinates are given, so do give me your suggestions. You may post your questions here, and if you like this video, do subscribe and pass on this video link to all your other 𝐴𝐴𝐿𝐴𝐿 friends who are working in other organizations. As well, please post this link in any group that you are a member which is working for energy conservation. So thank you very much for your listening. We will catch up again next fortnight. Do keep posting. Thank you. Bye-bye.